This is a great question because it is confusing. And the reason it's confusing is that we don't really know what's going on. These are rectangles that have hypothetical dimensions, right? We are never told how big this rectangle is. Everything is relative to these percentages. But that's not how the real world is. Rectangles have dimensions, okay? So we want to give this thing dimensions. We are going to have a much easier time here if we arithmetize. So draw a rectangle, okay? Now, I'm going to draw a very special rectangle. I want a square. And I want its length and width to be 10. That way it's easy to work with the dimensions. And I'm dealing with percentages, so a great number to work with when you have percentages is 100. And what's the area of this rectangle slash square that I made? It's 100. Okay, so that's going to make my life really easy. But let's just follow instructions from here, okay? Let's say we change this thing, and I'll just make it a little bit more oblong here. A rectangle is altered by increasing its length by 10%. So you might be able to do this in your head. 10% of 10 is 1, and so our new length is 11. So just to be clear, if we wanted to find 10% of this number, we could do this very simply. This is very standard percentages. So 10 is my length. 10% as a decimal would be 0.10, and so 10%, I don't know why I'm putting in the calculator, I know the answer, is 1, and so for increasing, then there's your 10 plus 1 is equal to 11. So that's a very traditional way of dealing with the percentages here. There are more advanced kind of SAT ways we could deal with it, but I think this question and explanation are already advanced enough. Let's just stick to the arithmetizing as the unique piece of this, okay? So this is great. I now have a dimension for my new rectangle. So check. But we're decreasing its width by p%. That I don't know. And that's not great because to have like a mystery percentage in math is really, really difficult. So I'm just going to put that aside for now. If these alterations decreased the area of the rectangle by 12%, well, okay, that's really helpful. Because a decrease of 12% from 100 means I just do 100 minus 12% of 100 is 12. So 100 minus 12 is 88. That's my new area. And we know that the area of a rectangle is length times width. So if the area is 88 and the length is 11, we can solve for the width just by simply dividing by 11, and we can see that the width is going to be 8. So now we go back to the original question here. We wanted the value of p. The width was decreased by p%. So it was decreased from 10 to 8. That's a decrease of 2. Okay? So 2 is what percent of 10? It's 20%. Again, because we chose 10, we can kind of do that in our heads, but if you needed the calculator, if you chose different numbers, for example, if you chose like, I don't know, 13, you'd get some weird decimals, but the math would still work out as long as you're consistent. So we could just say, okay, 10 times some percentage is equal to 2. This is why I want to use the old formula, but it's fine. So we would just divide by 10, and p would be 2 divided by 10, which is 0.2, which becomes 20%. So that's how you could do it in a very traditional way of thinking about percentages. You could also guess and check from that point if you weren't sure how to handle the mystery percentage. Just look at the choices, right? Just do 12% of 10, 15% of 10, 20% of 10, 22%. Only one of them is going to give you 8. So that can help. This question, I think, becomes so much easier when we have arithmetic to deal with instead of variables, because percentages are confusing as is. But then to take a percentage and make it a mystery, to have this random variable, is really hard mathematically for us to handle and mentally for us to handle. So what arithmetize does, in general, is it lets us get rid of variables that don't matter. We didn't really plug in for a variable here, though. The p kind of stayed a mystery till the end, but the general thing about arithmetize is it lets us visualize unknowns. So if we have something in a question that's unknown to us, and we're thinking, man, this question is confusing, it would be so much easier if I knew what this value was. That's your brain telling you, maybe try arithmetizing. If an unknown would be better if it were known, then try making something up. It can't hurt you, right? If you're confused, it's better than nothing. And most of the time, it will help you see things in the question, and you'll be able to get something that's very hard right. This is definitely a question that if you've been studying for a while and you know how to use your strategies, you're going to get this right, and the vast majority of people are going to get this wrong. So you're earning 10 points that most people aren't getting.